So I'm talking into the microphone because we're recording this, and so this is for the sake of other people. So it seems a little silly because there's not very many of us here. But
it also helps if you're trying to face your computers on some of the demonstrations.
Yeah, that's true. That's true. So I'm Sarah. I met a couple of you last time at the last meeting. I work here at Inside Sales. And so kind of my demo for the day is just like a getting started with Rust, kind of like an introduction to just some like basic setup. For most people, it's probably going to be really boring, but for a few, it might be really interesting. So yeah, we can just go ahead and get started with that. Hopefully it's going to take like 5-10 minutes max. If you have any questions, just holler. I will try to answer them. So my goal here is to do a side-by-side of Mac and Windows. So this is a fresh VM. I just barely installed it last night, so hopefully it's not horribly broken. So like the first thing with getting started is like actually installing Rust. And
Have it all open?
You could if you wanted to. Thank you. So installing Rust is super easy. On Windows, it can be a little bit more difficult if you need to install some like OpenSSL. If you want to use like certain C or C++ libraries with Rust, you'll need to install OpenSSL. So if you want to do that, then you have to install some of the like C++ compiler tools. So that's not too difficult, but I'm not going to do that step today because for most of the basic like Rust things, you're going to be fine. So to install Rust, it's on Windows, it's literally just downloading an exe file and then running the installer. So it's seriously so easy. I already have this installed. But so yeah, so basically click on this, download it, run it. This is telling us that it's going to install some stuff for us. We can just, if you want to be fancy, there's like custom installation tools, but we can just install with the normal installation tools. I don't know if anybody's following along, so if I'm really boring, just tell me. So then after you do that, though, Rust is installed. So I'm using PowerShell. So like one way we could figure out if Rust is installed is we could run rust C. And that will just kind of like show us that it's installed. This is the Rust compiler. This is like equivalent to GCC. So you can run rust C with like a basic RS file and make like a super simple like hello world program. So then on the Mac, it's, let's see, it's just a curl command. And that will install Rust with default installation. And then after we restart our shell, where's my mouse? There it is. After we restart our shell, we'll have the like Rust. Oops. Okay, so there you go. That's like how to install Rust. So that's not like the purpose of this talk. So the purpose is to kind of show some of the tools that are out there that can help you get started in actually programming it. So everybody has their own preference for text editors. I feel like Visual Studio Code has been my favorite, and I've used a couple different ones. I don't know how you guys feel about what's your guys' favorite? Vim, yeah.
I also heard Emacs, so not Emacs.
Eclipse?
The latest release is supposed to have pretty good Rust.
Yeah, I've heard IntelliJ is pretty decent.
That's probably the best word.
That's, yeah. The difficult thing about IntelliJ is it can be expensive. I think there's a community edition of IntelliJ though, so not sure. Yeah.
I think that Rust coding is actually free. I'm not too sure.
I haven't done Rust, but it's like the IDE. The question about the IDE is like install the plugin. Yeah, the plugin's free if you have a license to it. I don't know if the latest one is.
Yeah. Yeah.
I heard it works well with Sea Lion.
Sea Lion?
Yeah, that's their secret.
They like specialize their ID for different environments.
Okay.
Yeah.
Yeah. I've used like Atom with it before, and Atom's not too bad, but VS Code is pretty slick, at least from my experience. So, oh really? Oh.
Well, we had one trickle in. We haven't seen anybody wandering around besides Levi, so
Okay.
we started at 30. And
You already did.
Oh, sorry.
Great.
I didn't wait for you. I'm sorry.
No, that's fine. It's totally fine.
I figured it was like, I don't know, 7, it was like 7:20, 7:15, and I was like, oh, I guess.
That's great. All you've missed is Rust up.
Yeah, all you've missed is Rust Up. I just installed Rust Up.
I've done that before.
Okay. So anyway, downloading VS Code is easy. It's involving clicking this download button, and then on Windows, it's the same situation. So one thing that I like about VS Code, so this is VS Code right here. One thing that I like about it is it seems to me, like at least compared to some of the other text editors that I've used, that the package manager for it is pretty like easy to use and like easy to see. So this is really small, sorry. This is just like a super simple like program that I wrote just for the purpose of this presentation. And it's a password generator, so it does a few things. This is what a Rust file looks like. And so some of the extensions that I like personally are the RLS extension, which is just essentially like a linter. It does some code formatting and stuff. So that's easy to install. And then if you want to set up the debugger, which is pretty smooth in VS Code, there's another extension that helps set up the debugger, and that's called Rusty Code. You can install both of those things. The debugger is like built into VS Code. I'm not sure if you guys have ever used the debugger before, but it's like a built-in debugger that uses GDB, but it makes it pretty clean. You have like your, UI for it. You don't have to use the command line GDB, which is nice. So yeah, those are my 2 go-to extensions. They have other extensions that are probably wonderful, but and each of the extensions may need to be configured. A lot of times in the extension file, they have how you need to configure them in the extension details. Another thing that's probably worth mentioning is some of the tools. So to install Rust, you have to use Rust Up, which is just like the installer for Rust. And so it can help you manage different versions of Rust. So you can install nightly versions, which are unstable, or stable versions, which are stable. And So that's rest up. And then actually we have, is Anders coming?
Anders, as far as I know, he's coming, but he hasn't shown up yet.
Okay, so Anders was gonna talk about cargo, which is the cool part of Rust. It's like the package manager stuff. Oh, you're gonna talk about it?
Yes.
Oh, cool. Okay, so Eric's gonna talk about cargo.
Am I up now?
Mm-hmm.
Sweet.
Did you guys have any questions?
All right, I just need access to the guest Wi-Fi, and then I'm good to go.
Use inside sales guest. The password is capital inside capital guest. Capital I, capital P.
And then one thing that I wanted to ask is, I'm assuming that this is like too basic for everybody here, right? Like, it's okay if it's not.
That's a question.
Yeah.
So it's probably a part of the package install.
Okay, good. Tyler,
There you go.
you haven't? Okay. Were you trying to follow along and was like going way too fast?
No, so I've done the install,
Okay.
but
Yeah.
I started reading.
Mm-hmm. Yeah, the book is like, in my opinion, it's the best place to start and to do the walkthroughs with it. This little program that I've made, it's on my GitHub repo, but it's like a password generator. It has like some input to the you know, some standard input. It does some like random number generation, and you have some borrow checker stuff to look out for. So it's like a very like intro all around little program. And the book.
I got like the
Yeah. Then it will have you make like a little number guessing game, and it's really great. Okay, Eric, do you want to?
Just tell me where to plug in. Let's see. Over here. I like standing up and being running around in front.
You want to be in front of a camera, we actually do have a recording going on.
Sweet.
The sweet spot is basically what you see in that bottom.
Okay, so just a little to the right.
Pretty much the entirety of the camera and about another. If you stand just to the right of that screen, then you should be golden.
All right, so this right here, pretty much. Okay.
Testing. Okay. All right. And do you need to run anything for you? I don't think so.
Peters is 10 minutes away.
Is he? Okay. Awesome.
His laptop was in the wrong time zone.
Oh. Oh dear. All right, so I want to know how useful this talk is actually going to be for everybody before I start. Let's see, does that work? Okay, excellent. Can you see the pointer? Yes, you can see the pointer. Perfect. Okay, so how many of you would consider yourself newbie rustaceans? I raise a hand here. Okay, so majority of you. Okay, so a lot of you expressed that you were comfortable with Rust up already. How comfortable do you feel with cargo in general and writing Rust code? Meh? Does everybody already know stuff like cargo build, cargo run? Raise your hand if you don't. So everybody does know that here. Okay. Does everybody know about stuff like cargo doc and cargo publish? Raise your hand if you do know about cargo doc. Okay, majority of you. How about cargo publish? Has anybody actually published stuff to crates.io? Okay, cool. I have too, so that makes two of us between me and Ed. So I could just launch into a talk talking about, all the basics of cargo, but I don't want to give a presentation that's going to be mostly repetitious for you guys. So does anybody want a refresher on cargo basics? Go ahead and raise your hand if you do. Okay, that's about half the room. Everybody, I think I'll go ahead with that since we need to give Anders some time, but I'll try to make it exciting for you. Yeah, we're gonna have live coding. It's gonna be fun. So, just give everybody a refresher. I'm Eric Gubler. I'm the guy that's organized this meetup the last couple of times, and I'm the guy that's gone and bothered everybody numerous times about, hey, look, there's this meetup that's happening. You should come. So thanks for coming. We decided that for this meetup, generating content for newer stations would be the most interesting. Most of the people that we thought we'd be targeting did not come, so sorry about that. We figured we'd have more people from inside sales, but we do have a few. So at this point, cargo is our bread and butter in the REST tool chain, right? I wanted to make a quick application with everybody just to demonstrate the basics. We can blow through this so quick since you already know. We were going to make an application live, and we were going to make a doggo search application. Searching for dogs. Oh, yeah, because puppers are the best. Look at this guy. He's playing fetch. We need to gather, in more business speak, we need to gather business intelligence on the presence of doggos in this content that we type. So our app's going to be really simple. This is just going to be real fun here. We just need to process input from our user, from standard in line by line. And we only have one requirement for how we should print things out, which is if they enter a line that contains this substring doggo here, then we should print out text contains doggo, emphasis on the exclamation mark. The boss thinks this is really important. Otherwise, text does not contain doggo, right? To initialize your Rust repo, there are two commands you could use. Normally use cargo new because you don't have the folder already. But if you do have the folder you want made already, you can just do cargo init, right? Cargo init just does some really basic things for you. It creates two files. We'll look at that in a second. But really they do the same thing. They just copy the same starter template to a folder that you're initializing. And it looks something like this. So it'll create a manifest file here for Rust. That's called the cargo toml file, usually. And for applications, we start with our main.rs file. Everybody knows what this is, right? Is there anybody that is lost until this point? Okay, good. Main.rs is a nice convention for us. And after we have some code, which we start with, we have runnable code right from the get-go with cargo new and cargo init. We could just use cargo run, go through with it. So if you're using a library, you can use cargo build. Honestly, if you're just wanting to check if things compile, just use cargo check. Cargo check is fantastic because most of the time we spend compiling Rust right now is optimizing an LLVM. Cargo check just does the first couple of passes where it's checking syntax, semantics, borrow checking, type checking, all that stuff. There's no actual compilation happening, so way faster, way better for a tight feedback cycle if you're just trying to get things to compile. So add that to your toolkit if you didn't know about it. I have in this presentation a bunch of slides that we're going to have screenshots first, right, showing basically what we're kind of expecting. And then we'll have this. This is a demo slide. This is where we get dangerous and we actually start to write code live. This is where things can go horribly wrong. But yeah, also because I am used to presenting in a way where I don't want to ever forget what I'm doing. And sometimes I do. So it's nice to have these slides for me too. So let's really quickly implement this doggo search here. Unless, does anybody interested in that? It sounds like for most of you, this isn't new stuff so far. So I can just go through this if you want. This would basically just be writing a for loop and taking in standard in.lines after you do a buff reader on it. I would be more than happy to show you, because there's one guy I know that's totally new to this, and I'd be more than happy to show you after individually. I think that'd be a better learning experience, right? Okay. Nah, it's not crazy. Okay, so we will skip this for now. In fact, we don't have to do any of this implementation at all if we're already comfortable with cargo. So we basically just make a little function that contains doggo, takes a string, spits out a bool, and then we would, supposing if we were coming from JavaScript and trying out Rust, for instance, does anybody know the method that you would call in a string in JavaScript if you wanted to see if a substring was in there? There's no, if nobody knows, then that's totally fine. There's a couple of different approaches. Index of is the old way. Includes is the newfangled way. A lot of people add shims for that. But includes doesn't exist in Rust, right? In lots of other languages they use contains, and that's what's in Rust. But I was hoping to kind of drive it to be, okay, let's try includes. Oh, crap. Well, that's not it. What is it? It would be nice if we had some docs to lean on right now, right? So if you're ever just curious about the standard library, you have a question, you're not actually working on something, you could use doc.rustling.org. Standard path you're going to want to look at the standard documentation specifically. But if you just go to this domain name here, it'll redirect you to it. But if you've already used RustUp to install stuff, RustUp installs a ton of useful stuff, including documentation, right? Including the standard library documentation. You can actually run this from the command line to look at standard library docs. You don't have to have an internet connection. If you've already downloaded Rust, then you've downloaded this too. If you do RustUp doc without the standard flag right here, there's also lots of other goodies. You get the Rust programming language. Just by default, you get lots of other references for how to write unsafe code, how to write with macros, the Rust programming language. Oh, it's awesome. And I would say most of the materials that you get offline here are really what you should read first before you try to read other guides like too many linked lists in Rust or something like that. Another thing is Cargo Doc. Cargo Doc is fantastic. Does anybody know why? Can somebody tell me why Cargo Doc is so fantastic, maybe in your personal experience? We already have a knowledgeable audience, so I figure I might as well pick on somebody. Yes, it is. What's your experience with it? So you've written maybe some doc comments and on your stuff? Mm-hmm. Okay, so you mostly generated documentation for your own code then? Fantastic, awesome, thank you. Yes, Levi. Absolutely. Yes. Cargo Doc will include every single crate that you pull in inside of your Cargo Toml. When you add a dependency and you can actually get your stuff to compile and you run Cargo Doc, all of those crates will have their documentation generated too. So if you have a dependency you know you need and you have a question about it and you're on the subway or on the airplane or driving on the bus, well, you're probably not driving the bus, but you can access all of that offline too because you have the source code. Rust by default, most of the packages you pull down are going to have the source code included with it. So offline, local. You do have to get stuff to compile. That's not usually a huge deal, especially if you're making incremental change with your code, but you know that may or may not be, right? So if we wanted to look at the string API, we would just type in this command. It's nice and fast. I have a fancy Z shell set up, so let's see here. All right, Rust up. Oh, man. There we go. And it just opens this magically. Voila. Neat, right? So in this case, we would look in here, you know, and be like, hey, what's the string API? Oh, hey, cool. Here's string. Go through here. Oh, look, there's a str contains. That's not quite what I was looking for. But it does seem to do what I want. Look, here's the example. Is that kind of hard to read? I can beef up the text. Whoa. A little better, right? Any questions until this point? Okay, awesome. If you have any questions, by the way, feel totally free to just raise your hand, interrupt me. This is str right here. I searched for string, and then when I type in the search for contains, it brought up everything again from the standard library. So I clicked str contains. Sorry. I do not mean to be confusing. It just happens. It is. And so for everybody that's new to Rust, there are actually two different string interfaces here. There's full name string, which means you own this. You can change its buffer. You can do whatever you want with it. There's also the stir, which normally you use with just mutable borrows or other read-only interfaces that you want to provide. It basically just limits what API is actually available to use. There's a couple of other reasons that the Rust community did it historically, but those are the major ones. You can basically just think of this as a write-only string. So, any questions about that? None? All right. Let's see. I need to go back here. Cool. So yeah, this is what we would expect to see. This is the prompt in case I forgot to do it. One of the best parts about Rust that I really like is that writing your own docs that look just like the standard library is super easy. A lot of you already know this. But it's all you have to do is just add / comments over whatever it is you're doing. Oh man, you can barely see that red right there. I bet on the recording it's just fine though. So, does anybody know the difference between this / and then / in a bang? Anybody seen that before? I'm sure Ed has. I'm sure Levi has. No? This is an inner comment. So we have two styles of comment here. We have our outer comments, which is you put it above whatever it is you're going to be documenting. You also have inner comments. So this is line 1 of main.rs, right? When it doesn't look like this is attached to anything, but if you use an inner comment at the top of the entry point of your application or library, this will actually become the top level documentation for the whole crate, your whole package. Cool, right? And actually, if you look at something like Cargo Script, which I can show later, there's lots of fun tools that I have at the end in case we had time. It actually uses that so you can have an inline Cargo TOML manifest to run like a script. And we can show that fun trick in a little bit here. So this is the point where we would go to my editor and then write some docs, do an example, let you shout, holler at me, insert whatever curse words you want in the documentation, you know, that sort of fun stuff. And then you can see it with cargo doc open, right? So it operates a lot like the rust up doc --stud option. But I'm going to skip that here. I'm just going to show you the pretty screenshot that I took today. So you just do cargo doc open, and there you go. There's that comment that we had right there. Cool, right? We don't have the function exposed here because we didn't mark it with pub. So that's why it's not there. But let's see. All right. So has everybody done unit testing in their code? Raise your hand if you have not done unit testing with Cargo. Oh, really? Oh, good. We're starting to get into the part that people haven't heard of. This is so good. Okay, so if you want to write some unit tests for your code, Rust actually makes that insanely easy too. So all you need to do is you need to have a free-floating function that you put the test attribute on. It just needs to take no args and in our simple case, return nothing, and it will just get run when you run cargo test. So if I were to add tests to my contains doggo function here, all I would need to do is write this function. The name doesn't really matter. You use it when you want to like select specific tests to run, but in this case, we don't care, so I just call it test doggo. We put this attribute over here, crunch brackets test, and then I just assert that we have true, false for all of these different tests here. And it's kind of nice because after a fashion, this is a form of documentation too when you're looking at the source, right? Like if you're not positive how some edge cases should work, and if I'm doing good testing, you can see the edge cases like, oh, what should it do with a blank string? What should it do if doggo's over here instead of just the only thing in the string, right? So that's very nice. It's awesome for unit tests. They call it, most of the documentation you see about it talks about writing unit tests, but you can also write any form of tests you want, right? It's all code. So you can write integration tests, you can write more complicated tests in here. People have written entire CLI testing frameworks that use stuff like this too. Yep, looking at you, Ed. This is really great. This is something that's awesome to have out of the box, and I really wish we had it in C++ at my job right now. So when you run cargo test, it's going to look something like this. You say, all right, cargo test. It'll compile your stuff if it's not already. Usually it will need to because by default, if you do cargo run, cargo build, it will strip out all of your test code. There's no reason to have that in there. And it will run it. It will list all of the tests that it runs down here and then give you a final count of everything that passed, failed, was ignored, got measured. So yeah. Filtered out is when you can also add arguments past this point to say, hey, I want to run this specific test. Like I could say test underscore doggo and it just run that one. But since it's the only test I have in this suite, then who cares, right? So any questions about that until this point?
This will also run any examples of your documentation.
Yeah, that's another awesome thing about documentation in Rust specifically is that everything's formatted with Markdown. If you use fenced code blocks inside as examples in your code, Rust will automatically try to compile the content of those code blocks. It will try to run it. It will do lots of fun stuff with it. So you can actually write really good example documentation. And a lot of times that will save you from having to write unit tests. If you've got good enough documentation, then you don't have to write the really weird stuff in your unit tests. So yeah, if you want to test stuff in your README, I love Rust Skeptic. Skeptic's one of my favorites. Oh, really? Ooh, I'm learning new things. Yeah, and I'm actually really excited for that. I have that as an issue in a couple of my repos right now saying, hey, basically the top level documentation and the README say the same thing. So let's just inline the README once this finally stabilizes. So yeah, that's a great point. So did anybody miss that, by the way? Ed just had really good information there. So I should probably give you the mic when you speak. All right. So if you ever need to distribute your binaries, because you're being really successful in Rust and people actually like what you're writing, then distributing stuff is actually really easy because it all gets compiled into a single binary. You just need to know where it's located. The target folder gets created when you run, build, check, test, anything with cargo. Don't forget to do cargo build release if you're actually going to distribute stuff. Please don't. That's one of the comments I look for every time somebody talks about something that they're publishing on Reddit or benchmarks that they're running. It's like, did you remember to add the release flag? And it's surprisingly common that people forget that. But yeah, it's as easy as grabbing it out of this. So if you were to do cargo build release right here, I make a dist folder, from the web world. Everybody that writes web code should be familiar with that folder. It's kind of hard to see with this lighting right here, but from the target folder, release folder, in this case, doggo-search, since that's the name of the folder and the crate that I have, then we just copy it over to the dist and we're done. Yay! Put it into a zip file, put it on GitHub. Joy, stars. Everybody loves you. Questions? Yes.
Like how easy is it to build binaries for other architectures and other environments? So if you want to build the Linux or Mac OS or even ARM binaries, what do you have to? Yeah, cross compile. Yeah.
I know Levi is kind of qualified to answer this, and so is Ed. Do you guys want to answer first, or? Oh, there's another mic right here. Okay.
Is this working? Yes. Okay. So Cargo itself has some basic cross-compilation support, but when the platform has more, like, say, it requires linkers that aren't available on your system, things like that, there's a project called Cross. I think it's actually with an X that it starts with. I think so. I can't remember. That is actually what it'll basically do is it'll automatically like create Docker containers for other platforms, go and run Cargo with those, build it, and get you the results back out of that Docker container.
I've used some of the embedded tools like Xargo for targeting certain embedded platforms. I haven't done any like build up into binaries. Oops.
So it's not terribly difficult. I've cross-compiled for Windows and Mac from Linux. That wasn't too terrible. You do have to get some binaries from, there's a project on GitHub, and I don't remember what it's called, but if you search for cross-compiling for OS X, there's a project there. You pull some binaries. You have to download something from the App Store, and then you unzip some things. It does some magic, and then you get a GCC that will work for the linker that will work for OS X on Linux, so you can cross-compile for Darwin, and then you can also, the Windows part, it was easier. You just have to get the mean W toolchain on Linux. So on Linux, it's definitely doable. I've done that and distributed tools to teammates using that way, so it works.
It's Cross with a C. I was thinking of Xargo versus Cross. They're both related tools, so it's Cross with a C. Is there anything else with that?
Yeah, so in a nutshell, it's a more involved process, but there has been a lot of work to make it easier. And that's definitely something we can take a look at once we get to our hacking time after this. More than happy to help out with that if that's something that's important to you.
So something else, I don't remember if it's Xargo or Cross, but one of the two, they're actually looking at trying to upstream it into Cargo itself. And the other thing I was thinking of is, like, if you're an open source project, just go ahead and use a combination of AppVer and Travis. Like, just have them do the compilation for you rather than trying to do any cross compilation yourself. That's what I do.
All right. So we've shipped our Doggo searching app, and we have decided that we need to make our output text more colorful because that pleases the people that are at the head of our company, and it also should theoretically please our users. So the revised requirement has been, if we type a line of input containing the word Doggo, then our text contains Doggo message that gets printed needs to be green, and the text that does not contain Doggo needs to have its response printed in red. That makes sense to everybody? All right. We're going to figure out how to make that ADA accessible later because red and green are usually terrible combinations for that. But let's discuss, how would you implement these colors? What do you guys know about terminal colors? There are escape codes for it?
On Windows, it's a lot more complicated.
Probably find a crate. All right. That's not a bad idea. I mean, we do have Cargo. We have nice things. It lets us pull down dependencies for us, so why not, right? Also, writing that yourself is a pain. We're not C++ programmers. We don't have fun writing lots of stuff that's already been written already. I'm just kidding. I work in a C++ shop. I love doing that sometimes, but that's because I like learning how things work. But Rust does have a good ecosystem, and normally for really common needs like printing with colors, you really don't need to reinvent that wheel if you don't want to. If you want to, go right ahead. Please do it. Learning experiences are great, and Rust is definitely a great learning experience. But there is a good enough ecosystem for this. So pulling down dependencies, Rust packages are called crates. For the few people that here that aren't really familiar with it, the site that we have that hosts the infrastructure for all of the public packages associated with Rust is called crates.io. And this originally started out as somebody doing this for fun, but somebody actually made a docs.rs website. And all it does is it pulls down all of the packages available in crates.io, and it builds the documentation for everything. It's pretty sweet. You can do lots of window shopping before you ever download anything. It's very nice, especially once you get to know the URL structure. Then you just type it and bang it out. I love doing that. You're talking to the guy that has a Vim flow, though, so I like memorizing stuff like that. If a search box is your thing, just navigate to these links. They're easy. Anders is going to go into a little more detail here. I'll let him do that, but for all intents and purposes, let's look at the term color crate, because we have a friend that's been telling us all about it. Even Cargo uses the term color crate. That's fancy, right? Oh, wait. There's a problem. This isn't colorful enough. There we go. Yes, term color. Right now, the latest version is 0.3.4. So we're going to need that information in just a second. Let's take a quick peek at term colors documentation so we know how to use it. This is theoretically a step we could skip. Is anybody actually interested in this? Nah, Ed's kind of like, meh. Okay, I do have screenshots, so we do have a good enough substitute to doing it live. The easy way that I would do this is just type in this URL, right? You know, docs.rs/term color. Oh, I don't have a screenshot of the term color documentation, but I don't want to steal Anders' thunder, so we'll do this really fast. Docs.rs/term color. All right, I'm betting I'm going to need to beef up the text. Yes, I am. How's that? That work for everybody? A little more? How's that? All good? So once your documentation gets a little more beefy, this is what it starts to look like, right? You can actually recognize headers inside of your markdown. That's what it looks like. You can get links to it just by right-clicking it. Here's the example that we would probably have stolen if we were to actually do our live demo here. Here are the imports we would use. Here's some of the statements and expressions that we'd actually put inside if we were to use it. In this case, we're setting some text to green, printing it in standard out, which is the buffer that we got out. Any questions? What do you guys think about the verbosity of this? I know that if you compare it to a language like Ruby or JavaScript, it seems kind of verbose, doesn't it? AJ's over here like, oh my gosh. There's actually a reason. Yes, a lot of this verbosity is because you're getting a lot of control over your resource usage.
Let mutt buffwater.
So this mutt here, we can talk about this more for our hacking. I think that might be easier, but this is just saying, hey, I'm going to mutate this down the line. This is something I'm actually going to change. Everything in Rust is immutable by default, meaning if you try to call a method that mutates things, the compiler is going to yell at you. So it's really nice because then just by looking at function declarations or looking at variable declarations, you can tell, oh, is this thing going to change? Am I going to have to keep that in my head? So that's nice. That's one of my favorite parts about Rust, actually, is being able to get really good information like that just by looking at things being declared. All right. So everybody remembers the cargo.toml, right? This is where we had it originally when we called cargo new. So we need to edit this guy to add it to our dependencies. Rust has some great documentation. For our intents and purposes, we may or may not want to skip this, but this is the URL that you can find it at. It has everything you could possibly need. It has way more detail than we're ever going to get into here tonight. The thing that we need to take away from it is there is a dependency section. TOML files look a little bit like INI files where they have sections and brackets, right? But it's a little more sane and you can get a little more complicated. It's actually very comparable to YAML in the kind of configurations you can get. Underneath our dependencies section, which is generated in our default cargo toml files, we're going to add term color. And by default, you can just do equals version number, and that's it. It's kind of easy. It's kind of like adding something to our package JSON from the NPM world, right? Pretty easy. There are also CLI tools that will just do it for you. Cargo edit is one of them. We'll talk about that in a little bit. And in this case, you just do cargo add term color, and then it gets the latest version for you and put it in your cargo toml. So, any questions about that? Pretty easy, right? Here's what our cargo toml would look like, just for everybody's benefit here. Pretty straightforward. One of the strengths I think that Cargo has is that everything is by convention as opposed to configuration. If you do a really heavyweight tool like Maven, you'll know what I mean. Tons of XML. Cargo has a lot of defaults, and you can override lots of those defaults, but most people don't ever have a reason to go against it. And so if you're one of those people, then you can have really small cargo tomls like this. Just as a side note, everything in the Rust ecosystem usually follows semantic versioning. So what you're saying here is not actually, hey, give me 0.3.4, but you're saying, give me something that's semver compatible with this. So usually in this case, if I recall right, and Ed, you're going to have to correct me here if I'm wrong, this would also accept patch releases, mainly stuff associated with bug fixes or really, really, really minor additions to your code. Like 0.3.5 would get accepted, 0.3.6, but it would not download like 0.4, right? Because this is a 0 dot number. It would reject that because this is technically the major version number right here. Yes? Microphone? Can you get a microphone over here? Thank you.
And if you want to, maybe you'll get to this, but there's a cargo lock, right? So isn't there a way to tell it to compile saying only use the exact version in the lock file so that it doesn't, in case you don't want patch versions, it'll do that. It'll just get exactly what you have in there.
Absolutely, yeah. So whenever you start compiling stuff, with an entirely new cargo toml manifest and you don't already have a cargo.lock file at the top level, it will generate one for you and it will describe the exact versions of dependencies that Cargo has pulled down and has compiled your stuff with. It is encouraged that you do this when you're writing applications. It's not encouragement for writing libraries, but a cargo lock does generated even if you are building a library. So Ed?
So yeah, basically like unless you check it into source control, it's only locking it down until your tree is cleared or you share your code with somebody else or whatever else like that. There are weird symbols you can put into the cargo.toml file. Like if you're like, okay, there's a bug in the newer version, I need to lock down to the specific one, you can actually specify that in your cargo.toml.
Yeah, kind of like in a package JSON where you can have like a caret over here or an equal sign saying, no, just this is explicitly what I want. You can do that with Rust too. It follows a lot of the same convention. So, any other questions? That was a great question, by the way, or comment that turned into a question. All right. So, now that we have imported term color into our project, we are basically good to go. It's really hard to see here, but this says extern crate term color. And then we have these import statements from the sample code that we bring in, right? This is how you bring in external dependencies inside of your code after you put it in the manifest. Extern crate name should be the same name that you have in your cargo toml. And then from this point, you can just use on it. You can also do absolute paths. So you can do : term color, : color, for instance, if you were writing this in the middle of a function. But if you're just going to use like use statement here and just bring it straight in so you can just use the name, then yeah, you can just do use term color. And you can have compound import statements like this with braces, right? So brace, color, comma, color choice, comma, color spec. And these can be nested like a great big tree. In fact, this is my preferred style, is to have a huge set of a single use keyword and then usually an open brace and a closed brace and then just have everything inside. I like it that way. I think it's a lot easier to read than doing use blah, use blah, use blah. Technically, it's easier to grok if you're looking at a git commit, right? But I like optimizing for code that's readable when you're actually looking at it in an editor. So that's just me. That's just personal taste. Okay.
Oh, oops, my bad. Okay, I'll humble myself and take a mic as if I was, So, term color, : bracket color. Am I to assume that this means that I could just use color lower down? Like it brings it out of the namespace, or do I still need to do term color, : color?
It brings it out of the namespace in this case. That's why you would use the use in this case. You don't need the use if you're going to absolutely qualify it.
Oh, okay.
Like if you were to do term color, : color inside of your code somewhere, that's it. That's a fully qualified path. You're done.
Now, color is pretty common. Right is certainly very common. I'm assuming there are other packages with names like color, right, and standard stream. So in those cases, can I not use the use and I have to declare everything with the package name and colons?
You can give them your own labels. So very similar to like in Node, you can do color as term color.
Color as, okay,
or
cool.
color choice as term color choice, or CC, or underscore whatever, whatever you want to do.
I like it.
All right.
So so specifically with the IO write, that's actually something a little bit different. That's actually a trait, and the only way to make a trait, basically it adds extra functions to some structs, and the only way to add those extra functions is to actually bring it in that way. Other than that, you don't, I personally just don't even actually, I only do the use top level, I don't do the other stuff. The convention is if it's a struct or a trait, you go ahead and do that. If it's a function, you actually use the, you don't actually fully pull it in.
So how do you scope it in the case that something else has a trait called right?
That actually, for that specific case, that's a little bit of a difference because that one's so common that I don't think anyone else is going to name their trait right. But in other cases, if you need to pull it, I'm assuming you would just hack it up by using as, even though you almost never directly reference the trait because the functions get added to other structs.
Yeah, so for write, for instance, there are certain structs like standard out, for instance. If you can pull those in from the standard IO module and they implement the write trait, which you can think of as an interface, right? Yeah. But you can't actually use anything associated with the write interface or trait in this case until you bring it into scope, right? So if you were to do standard out dot write whatever, right? You can't actually use that until you bring it into scope. Normally, even if
I did an as, would I then have to do dot whatever the as is? So standard out dot.
No. The only problem will come when you have two traits that specify the same name from a method, which is really rare. There is disambiguation syntax for that in Rust. It's called a turbofish. But that's pretty rare and not usually something that you need to be concerned about, but we'd be more than happy to help you out with that.
Well, I don't want to take us too far off the course here. I'm just trying to grok it all.
Sure, absolutely. Let's see. There we go. I'm back where I was. So this is the function that I probably would have proposed rewrite if we were to print a colored message. You just take a string and then you say, hey, here's the color you should print it as. It will reset the color of standard out in this case to not have any special coloring. And so you can kind of just think of it as a one-off, like, all right, print this, and then we can do something else with our lives, right? Let's see, I don't have any other thoughts about this, except this has a result type, and this is something that we were probably going to get questions about and talk a bit more about during hack time. It's a pretty fundamental type. for error handling. In fact, it's the type for error handling. We don't have normal exceptions in Rust. We have returning values that say, hey, either I'm the result you wanted or I'm an error that you didn't want, but you get to handle anyway. So yeah, it's similar. You can think of it conceptually as being similar to using return codes in C, except way cleaner, way easier on your sanity and to read. So yeah, we will. This is probably one of the topics we should cover in the future once we start getting to more intermediate, more basic Rust and not just the tool chain. All right. So we would have implemented this in our interactive demo. And it would look something like this. I type this has doggos. It prints a green message saying, look, it does contain a doggo. If you said this does not, then you get a red message that in its lighting is hard to read, but it says this does not contain a doggo. Cool. At this point, yes. Nothing wrapped in here. Yeah, no problem. And at this point, we would have impressed all of you as customers and encouraged you to buy our Doggo Business Intelligence product. Yes. So, business is booming. You're now leading a team of engineers, kind of like Glade over here, writing Rust. And you want to share your critical Doggo domain logic with other products that you're building as part of your portfolio. So we need to make a library. How do we make a library with Cargo? I bet some of you know the answer already. Sorry? Yeah, if you wanted to make a library with Cargo and you were starting from scratch, then you would just do --lib, right? So cargo new --lib or cargo init --lib. That's one way we could do it. If we have existing code, like in an application, for instance, we can actually make the transition just as easy by making a lib.rs file too. So if we have our contains doggo function and we move it over to lib.rs, we can move our tests with it too, all of our docs. All we need to do is just literally just copy and paste it. This lib.rs is a convention for the library's entry point, right? This is the root of a library. And literally the copy paste is all you need to do. You would have an instant library. You can do cargo publish and boom, out it goes to the ecosystem for everybody else to use. Neat, right? The cool thing is that main.rs and lib.rs can coexist. You can have both of them. You can structure your application as a library and then write your own front end over it and then provide it to the ecosystem easily so that other people can just use your stuff. So if you were to write like a Rust implementation of Git, for instance, right? You'd have the Git command, but there's also like libgit2 that you'd use. And guess what? In this case, we would just say, hey, libgit2 is equal to lib.rs. In this case, you know, in your head, not literally in code or anything. That's not precise stuff you'd write. But it really helps when you're breaking things out. I use this all the time once my stuff starts to get larger and I'm like, you know what? It'd be great if this would be a library because there's some domain specific stuff here that I really don't need to keep the details in my application. So really good for abstracting stuff out, really good for transitioning your components as you're going and breaking them out. And honestly, coming from the C++ world, that's so handy. I've spent the last 2 weeks making a single component for the Chromium embedded framework, for instance, and that's just shoehorning stuff into a structure that's actually not dissimilar from how Cargo does it by default, by convention. So yeah, that's been fun. So once we are ready to ship our awesome Doggo library into production, probably in a vendor server in this case, so not out to the public because this sounds pretty proprietary, right? But if you were to make it open source, you would just sign into crates.io. Once you create an account on crates.io, you can get a token for publishing stuff from your machine. When you run cargo publish for the first time, you'll provide it as an argument, and off it goes. It gets packaged up. It's ready to be used by other Rust applications. And then the process for using your library is just as easy as it was for the term color library. Just drop in your cargo toml and boom, you're done. And then you profit because Rust has given you a competitive advantage. Any questions so far? Great. All right, so let's review. Everybody already knew about basically all of this stuff. We learned a little bit about cargo test, which I thought was awesome. If any of you want more one-on-one time for any of these things too, feel free to just pull me back and say, hey, for a hack time, I would like you to teach me more. Sounds good. I'll do it. But from starting to write new code to publishing it out, that's basically the whole life cycle. Cargo handles your whole life cycle of code. That's why we call it your bread and butter is Rust. It's awesome, right? If only every language did this. I think that one of my favorite parts of Cargo is I think it sets a fantastic example for how new aspiring languages can be and what sort of experience they can provide for Rust. I think between Rust Up and Cargo, that was part of what hooked me into getting into Rust is, man, this is easy. Why isn't the other stuff I've used this easy? So anyway, here are some other neat tools. We've talked about, we've referenced some of them here, like Cargo Edit and Cargo Script. The Rust community has done a fantastic job of providing other tools that not every developer may need, but are very helpful. There's the linter, specifically called Clippy, that I really like. It's very pedantic. It will help you iron out some very real issues in your code. It will also help you to iron out things that you don't think are issues. Rest format is also one of my favorite formatting tools because it is dang easy to use and it is dang easy to configure. So I would love to tell you any of you more about that if you're curious after this. And another one of my favorite parts is that there has been a huge, huge, huge push to get really good continuous integration configuration. And it is so easy now. There are some standard, like Travis CI has an awesome config that I've been working with CAD97 on called Great CI. You just literally copy paste his Travis.yaml file and drop it in your GitHub repo, and you're good to go. You've got CI for the Linux platform. There's no really great option I know for AppVeyor yet. I've got a couple of configs that I made, and I'm considering making one, and I'm sure Ed is going to correct me now. Microphone.
So I've actually, one of my goals has been stop the great mess of all of the blog posts that quickly get out of date and actually centralize knowledge. There's actually a website, crate-ci.github.io. It actually steps you through like piecemeal parts of both AppVeyor and Travis configuration. Be like, oh, I want this functionality. I want to have it automatically enforce my style checking as part of my build. You just copy the chunk out of there, paste it into your thing, and it's using all the best practices that have been found over many broken builds over the last year that I've had, plus any other blog posts that I've come across on those kinds of topics. So crate-ci, just search for that and you can be able to find the GitHub webpage.
All right, yeah, and we can look at that after this in a second. I personally really love Cargo Script because it lets you have a single self-contained script file, and Rust is actually really fantastic for scripting because there are some really, really good crates for managing computers, for talking to Linux internals, for instance. And if you are able to just keep your TOML file as a single inner comment for the top level of your code, it's really easy to maintain. It's all just a single file, and usually most scripts you write in Rust are going to be less than a few hundred lines of code because it can be that expressive. It really can. Cargo Edit is kind of like, it'll provide npm install like flow for stuff, you know, npm install this dependency, npm install that dependency. It's Cargo Add, Cargo RM. It's fantastic. You should go and look at it. It is really nice for when you're just banging stuff out and you just want to keep going. So those would be my suggestions, and that's all that I have for this presentation. Whew, all 60 slides. Wow. Does anybody have any other questions before we go on to Understock? All right. Thank you. You guys have been great.
Start a whole
What I had developed in pack.
Okay.
Sorry for the delay, everyone. Also, I want to apologize up front for being super late. If there was any panic induced, I just moved here from Arizona, and my laptop is still on Arizona time. I was sitting in the library down the street doing absolutely nothing useful, just waiting for the clock to roll around. So once I looked at my phone, I definitely panicked. So it's kind of weird, like talking to you all behind me, but I'll just pretend like this is how I normally talk to people. This is going to be pretty high level from the perspective of somebody who's like never really used Rust before. However, it will also be pretty short and sweet. So I think we'll be able to get through it quickly. I have like 6 slides, and then we're just kind of running through a little bit of example code from a little project idea. So I'm talking about the Rust ecosystem. If somebody was starting a new application, what are some of the steps that they would go through the process, kind of in a simplified version? As a motivating example, we're going to imagine that this person wants to make an application that just part of what it needs to do is have 2 points in 2D space and to find the distance between them. I've been doing a lot of like graphics programming and stuff lately, and so these are like libraries that I've been using recently. So the first thing we're going to do is come over to the code part. And just like Eric was doing, I'm going to use cargo and create a new, we'll just call it example 2, because I already have an example 1 in there. And so we've created a binary project for Rust. And we can run it. And from the niceness that is cargo, everything just works, which is great. So we've kind of got the project up and running. And sorry, this my window manager is not ideal for picking this mic up and down. Oh, we're going to do this. All right, so I can just set this mic. All right, you're awesome. He's going to hold it for me. Okay, it'll let me go a lot faster. Everybody will be happier because of that. So we got our project. And now we the first question is, okay, well, how do I get my personal code that I'm writing to work? How do I learn about Rust? And the most basic place to go is just to the Rust documentation, which is pretty obvious. And I recommend pretty much starting with the Rust programming language book, the TRPL, they like to call it. And they're currently on the 2nd edition. It's really good. And it's great to just kind of read through the whole thing, and it'll give you a good understanding of what Rust is about and how it works without getting too crazy about the details and stuff. You can even get it in print. This is what that looks like. I just got mine a couple weeks ago. It's pretty exciting. It's well written, and even though you can buy it in print, it's available freely online as well to read the whole thing. So from that, you would have, at that point, you would have learned how to go in and make basic modifications to this default application that comes in. So what I'm going to do is I've got VS Code here, and I don't normally use VS Code, but I know that the first talk did. So I'm going to go ahead and open up that directory so we can see our project here. And we've got the default code that was put in here, and from reading just the basic stuff, we can make a simple modification to our source code. Come over here, rerun cargo, and see that we're able to have those modifications. Great, so we've made a very basic change. So now the question becomes, all right, how do we take this code and start being able to represent points in space and do operations on those? Obviously, we could write it from scratch if we wanted to, but there's lots of great libraries out there to do that. So next place that we want to go is Google, obviously. So if you just do a search for Rust, and we want a linear algebra library. You Google this, and you can kind of see that there are a couple GitHub repos that look like they're fairly hit easily. This one appears in GitHub, and here, an algebra library, which is a popular one. This is my personal favorite, a Reddit post. Why are there so many linear algebra crates? I'm sure that is a great, useful conversation that we are not going to participate in. an alternative is to go to crates.io, which is the, Eric was talking about a little bit. This is the community crate registry. And you can do that same search that we just did, linear algebra. And now you can kind of see these are, I recognize these results, some of them from the Google search. However, there's some nice things built into crates.io that can help us sort of get a better idea of what we're looking for. First thing you can do, instead of sorting by relevance, you can sort by the number of downloads. And you can see that kind of brings some different ones to the top. And you can do it all-time downloads, you can do recent downloads. And the one that we're going to use, because I've used it before, and it's kind of a more minimal math library, is CG Math, which is short for computer graphics math. If you, I think the most generally accepted popular one for this is NAlgebra, but I am more familiar with CG Math because it fit well for the project I was doing. So we can come in here and we can see that there's a little bit of documentation and some more stats about how much this library is used. One of my favorite features about crates is that crates.io is you can also click on this dependent crates, and you can, it shows you what crates have this crate as a dependency, which also can be really helpful in, especially as you have spend more time in the Rust community. You'll recognize some of the names in here: Glium, Rodeo, Specs. Those are all are very popular projects. So it gives you some confidence that CG Math is a good choice, or at least well battle tested. All right, so we're gonna go ahead and assume that this is the one that we want. You click this button, it copies your dependency line, and then you can come over here to our code, open up your cargo toml, and all you have to do is paste it in there, save the file, come back over here, run cargo again. And I already have this version downloaded, but if you didn't, it would download the version that you need, update everything. It takes care of it automatically just from updating your cargo.toml. While that's compiling and rerunning, I'm going to go ahead and come back to the code, and we're going to start implementing this. So the first thing that you need to do to use the library is you have to extern in the crate. So we're going to extern in CG Math, and then now we can come back here and click on this documentation button, and this takes us to the site that Eric was talking about, the doc.rs, which has the documentation for everything on crates.io. And now we're going to ignore this part up here for right now because this is actually really useful information, which is good. However, many crates that you are going to come across are not going to have this. The developers have to explicitly add this to their project. Oftentimes you'll come in and you're just going to kind of see this whole list of crates, of macros, structs, traits, and things like that, and it can be kind of confusing about what does what. However, coming from, most people have some object-oriented background, you would kind of assume that you want to look at these structs. So sure enough, you come down here, kind of look, okay, we got some matrices, we got points, vectors, and if you'll remember, our goal is to find the distance between two different points. Now, semantically speaking, we'd probably want to use two-dimensional points for those, but we're going to go ahead and use vectors for everything to just kind of keep things a little bit more streamlined and simple. So we'll click on the vectors here, vector 2D, and sure enough, it looks like this is kind of got what we need. Got X and Y points. There's some methods here. So this looks like the correct thing. So we're going to come back to the code, and we're just going to hack in a couple things here. Now, in the interest of time, I'm going to copy this from the other example that I already did, just so we don't have to do it, and so that this guy doesn't have to hold this mic forever. Okay, so we've created 2 points, and we're representing them with vectors, and one is that they're both on the x equals y line. One's at 1, 1, the other's at 2, 2, and we can save that, come over here, and if we run it, we're going to get an error. And the reason is because vector 2D is not found in this scope. And the nice thing is that if you look here, Rust actually, the compiler tells you exactly what is wrong. It says possible candidate is found, is this what you want? And sure enough, that is what we want. We're just going to copy it, come back over here, and paste in that use statement. So that brings vector2 into this scope here. And now, if I'm not mistaken, that should work now. Okay, we're just getting a couple warnings about it not being used, but it does compile, and you see the little hi there message is printed out once again. All right, so we've got our 2 points. Now the next thing we want to do is we want to get the difference between those two, which will be a third vector. So we'll just call it diff, and that equals point B minus point A. This is going to return a vector. And then let's go ahead and print that out so that we can just kind of get an idea of what we're working with here. So this will be this little syntax here is for a debug print, the colon question mark, and we'll print out diff. Come back over here, run it again. Okay, so you can see that it is debug printing out that it's a vector with 1, which is the correct vector from the 0.11 to the 0.22. Alrighty, so now the final piece of implementing this is, okay, how do we get the difference of that? Again, we could do it manually just with what we know about linear algebra and calculating those points. However, this is the type of thing that we would expect our math library to provide for us, the way to find the length of that diff vector. So if we come back over here to our documentation, typically, again, coming from an object-oriented world, you're like, all right, here's my state, now where's my behavior? And you scroll down and you're like, okay, here's some methods here, but pretty quick you get into this whole list of traits and implementations, and it's very, very unclear what this is doing and where the methods are that you can call on this data type. And the solution to this that I've found that has worked really well for me is that you need to kind of invert your thinking, because Rust is not an object-oriented language. The way that Rust works is you have your state represented by structs, but your behavior is represented by traits. And so what you want to do is kind of roll back to the front page of the library and scroll down to the trait section and look for the behavior that does what you expect. And rather than making you read all these, I will give you a spoiler and tell you that it's this inner space one, and it says vectors that also have a dot or inner product. And as we know, in order to do the magnitude of a vector, you want something with a dot product. It has to have a dot product. So inner space is what we want. Click on that. This inner space trait, sure enough, bam, here we go. Here are the methods that we want to calculate specifically the magnitude of that new difference vector. The one final piece there is that if you scroll down, you can look at the implementers, and sure enough, here is vector2 that we're using, implements inner space, and so it just kind of makes it easier to tell. You can come back over here to vector2, and then even knowing the name of that, it can be hard to find it in this list, so I just like to search, and come down here, and then bam, there it is right there in the middle of all of these implementations. If you expand this, then you can see, okay, yeah, sure enough, vector2 has magnitude implemented for it. So all that talking, we can come back over here and simply change this to diff.magnitude. We are going to get one more useful error out of this. And the error in this case is that that trait is not in this scope. But once again, the compiler tells us, okay, you need to include that trait in order to use it. This is one of the things I have found to be somewhat counterintuitive and confusing. Sometimes it's hard to know where to get those from. But overall, the compiler typically helps you a lot to figure it out. And then there you go. There's the magnitude of the vector. There's the difference between those original two places. The only other thing that I want to say about crates is that it can be super useful. This button on the right here, this src, the source, if you click on it, it'll actually bring up in the browser the source code for that implementation. And it's kind of cool to see how the sausage is made. And I tend to forget that it's not magic, right? You know, at the end of the day, the stuff is just all code. It's not like hand-coded assembly or anything. It's all written in Rust, and clicked on the wrong one, normalize. Here's the magnitude. It's just the square root of magnitude 2. And magnitude 2 is simply the dot product. So that is another useful feature if you want to look at the source for what you're doing. All right, so we got there, we covered that. Here are just some other useful links. I will leave that up for a second in case anybody has any questions. No? All right, excellent, thanks a lot.